Welcome to the DIY Honda Garage channel. The DTC P1078 indicates that the intake manifold tuning IMT valve is stuck in a low RPM position. The IMT valve plays a crucial role in optimizing engine performance by adjusting airflow to the engine's intake manifold based on the RPM. Typically located within the intake manifold assembly, the IMT valve helps enhance fuel efficiency and power delivery across different engine speeds. When the IMT valve is stuck, it can lead to issues such as poor engine performance, reduced fuel economy, and potential engine misfires. The error often arises when sensors detect a malfunction, inhibiting the valve's ability to operate effectively. Understanding the context of this DTC is vital for effective troubleshooting and repair. The intake manifold tuning valve, or IMT valve, has a crucial function in ensuring that the engine receives the correct airflow at varied RPM levels. This component resides within the intake manifold and is activated to adjust airflow depending on the engine's speed and load conditions. When functioning correctly, the IMT valve enhances fuel mixture and combustion efficiency, ultimately improving overall engine performance. Once it becomes stuck in a low RPM position, it can create a notable deficiency in power and efficiency by restricting optimal airflow. The vehicle's sensors monitor the IMT valve's operation, and DTC P1078 is generated when the system identifies an issue. Therefore, understanding the location and function of this component is essential for diagnosing and resolving the trouble code. Several factors may lead to the appearance of DTC P1078. First, a malfunction in the IMT actuator itself is a primary suspect. It may be unable to respond correctly to the engine control unit's commands. Additionally, poor electrical connections or loose terminals at both the IMT actuator and the powertrain control module, or PCM, can lead to signal disruptions. Wiring issues, including shorts or breaks in the wiring harness connecting the actuator to the PCM, represent another potential cause. Each of these elements must be evaluated thoroughly to ascertain any component failures. A methodical approach to diagnosing and fixing these issues is vital to restoring normal IMT operation and engine performance. Drivers experiencing issues related to DTC P1078 may notice a multitude of symptoms indicating a problem with the IMT valve system. Reduced engine performance is typically prominent, as the vehicle can feel sluggish and may struggle under load conditions. Poor fuel economy is another common symptom. The inefficient air-fuel mixture due to a stuck IMT valve can lead to increased fuel consumption. Additionally, potential misfires may occur as the engine fails to receive adequate airflow for efficient combustion. Observing these symptoms can provide critical insights during the diagnostic process. It is essential to address these issues promptly to avoid long-term damage to the engine and ensure optimal driving conditions. The first step in troubleshooting DTC P1078 involves preparing for the diagnostic process. Turn the ignition switch to the on second position, which powers up the electrical systems without starting the engine. Before proceeding, it's vital to record all freeze and snapshot data, as it provides a historical context of the vehicle's parameters leading up to the fault. Additionally, reviewing general troubleshooting information will help you understand the expected behaviors of the components involved. Gathering this information lays the groundwork for subsequent steps and ensures a thorough and informed diagnostic process. This foundational task is essential to identifying and addressing the imbalances affecting the IMT system. For the second troubleshooting step, utilize the Honda Diagnostics System, or HDS, to clear the DTC P1078. Clearing the code allows the onboard system to reset its error log, and can sometimes resolve temporary issues directly associated with the IMT valve operation. Ensure that the HDS is correctly connected and functioning before carrying this out. After clearing the code, navigate the HDS to perform the IMT test, which falls under the inspection menu. This test will help determine whether the valve operates correctly under specified conditions. Monitoring the results closely is essential, as it will guide the next steps in the troubleshooting process. Once you have completed the IMT test via the HDS, assess the test result. If the outcome indicates that the system is functioning correctly, this suggests an intermittent failure, and your next focus should be on checking for any poor connections or loose terminals found at the IMT actuator or the PCM. An intermittent issue may not present itself consistently and can be misdiagnosed, so thorough checks are crucial. On the other hand, if the test result indicates failure, you will need to proceed to step 4 for further evaluation. Having a structured method to address the results of this test is key to effective diagnosis. In this step, first turn the ignition switch to the lock 0 position, ensuring that the ignition system is fully powered down for safety while working on the vehicle. Next, disconnect the IMT actuator by unplugging the 5P connector. This action isolates the actuator for the following tests. Disconnecting the actuator is essential to check for any electrical issues separately from the component's mechanical function. Once the actuator is disconnected, prepare to examine electrical inputs related to this actuator in the next step. Proper disconnection is a vital part of ensuring that you're not inadvertently affecting any test results or causing potential faults during the testing process. With the IMT actuator disconnected, it's time to turn the ignition switch back to on. This allows you to check the state of the IMT valve switch using the HDS data list. It is crucial to monitor whether the IMT valve switch indicates as close or not, which will determine the next steps in your troubleshooting process. If close is indicated, it suggests that there are no immediate issues with the valve operation, granting you to proceed to step 12 for further checks. If it does not indicate close, you will continue to step 8 for more in-depth diagnostics. Keeping a close eye on this data can be pivotal in guiding your troubleshooting effectively. After evaluating the IMT valve switch data, turn the ignition switch back to lock 0 once more. In this step, you will need to jump the SCS line using the HDS. This action ensures that the system is in proper diagnostic mode and avoids any erroneous readings caused by the onboard systems. Next, disconnect PCM connector B49P, which connects the PCM to a variety of engine sensors and actuators, including the IMT actuator. This disconnection is necessary to isolate the PCM from the diagnostic process, allowing for the following continuity checks. Properly executing this step can prevent complications in further diagnostics. With the PCM connector B disconnected, check for continuity between terminal B19 of the PCM connector and body ground. This step is essential for diagnosing any shorts or breaks in the wire connecting the PCM to the IMT actuator. A test for continuity will establish whether this connection is intact or if there is a fault lying in the wiring harness. This terminal specifically refers to the signal from the PCM to the IMT actuator. If continuity is confirmed, proceed to repair any short in the wiring and move on to step 24. However, if continuity fails, further exploration is necessary, leading you to step 31 for additional analysis. Taking time to ensure accuracy in this procedure can prevent misdiagnosis and ensure the right path forward. Once repairs have been completed, it is crucial to verify that all connections are secure and functioning as intended. Ensure that any wiring or component replacements are meticulously checked for proper installation. After confirming repairs, proceed to test the IMT valve function again using the HDS. This verification process can help confirm whether the repairs effectively address the original issue. Next, clear the DTC to reset the system and allow for fresh data collection. A road test should then be conducted to evaluate the overall performance of the engine under real operating conditions. The combination of these steps will assure that the vehicle operates correctly and that the DTC does not return. Preventive maintenance plays a crucial role in avoiding issues related to the IMT valve and potential DTC P1078 occurrences. Regular inspections of the IMT actuator are necessary to catch early signs of wear or failure. Cleaning and securing electrical connections can prevent signal disruptions caused by rust or corrosion. Checking wiring continuity and insulation can also safeguard against shorts or other failures. Conducting these maintenance tasks at regular intervals will optimize the IMT system's performance and increase the longevity of the engine's components. This proactive approach will help ensure that your Honda Odyssey continues to run efficiently and effectively, reducing the likelihood of encountering issues down the road. In summary, understanding the function of the IMT valve is crucial for effective diagnostics concerning DTC P1078. A structured approach to troubleshooting, beginning from obtaining freeze data to performing continuity tests, is essential in isolating faults correctly. Recognizing potential failure points allows you to address electrical connections and the actuator directly. Regular preventive maintenance can significantly reduce the chances of encountering these issues in the future. By following these guidelines, you can ensure optimal performance for your Honda Odyssey, promoting longevity and reliability. Overall, being proactive and informed is key to tackling automotive troubleshooting challenges confidently. Please like and subscribe to the channel. See you next time.